Okay, so welcome back to the class, and I'm trying to set up the password the password for this class, and hopefully that everybody get there. And um, how the exam going so far? Hello. Okay, so anyhow, let me just. It was okay. Um, I'm glad to hear that everybody stays safe and healthy during a very difficult time in New York City, right? And I hope that everybody continues to stay safe. And again, that I'm gonna grade and let people know the grade on Wednesday. Okay, very soon that'll be uploaded there. But at the end of class today, if anyone want to get their exam graded, I will basically grade for that as well. Um, So again, that the solutions basically on Blackboard, if you did not submit the solutions on time, for example, that um, I believe that we are having a certain um, group, for example, that I checked I did not know how many of you who actually submitted, but I can say um, by looking at the things that we have. And I would say there are only 11 people submitted the exam. What about the rest? I don't see all of you doing that. So there were a couple of people who actually have some trouble submitting the exam. Kevin's here, and let me just double check that. Um, yeah, so he's not here. Actually, this is gonna be like a big deal because as 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 I said, if you don't submit the exam, that's gonna be really hard for me. Okay, so but again, that if there are certain things happening, and you have to email me. Are we meeting on Wednesday? So I believe that we have no class on Wednesday, because of the Jews holiday for that, right? And so we're not gonna meet on Wednesday. So that would be a thing. Again, that we're gonna check the calendar, and so I do not really want to give you guys a lot of work and a lot of pressure. You see that I just basically stopped giving us some homework problems because so many of you submitted the homework late, but started after the second exam. So today there will be some new homework posted for chapter 9, and then when we come back next Monday, and that will be the starter for chapter 10. To be honest, I actually have it planned. Actually, click on 10.1 and 10.2 already. But since I really need to keep everybody on the same page, so it might be a little bit sluggish. I mean, a little bit lag between the period of time for us to submit the classwork and the homework problem. But however, that again, that when we start a new chapter, I really want to get everybody together for that lecture. So the faster, the sooner we prepare, the better we are on a final exam. So that being said, if you did not basically did so well on the second exam, so the final exam still be a chance that we can do really well. So that would be the same type of format that we have earlier. Um, the only thing that going to make it different is the final exam going to be um, triple harder than the second exam. So that as I can say that the second exam wasn't doing really well. I got some email. I got some email from you guys saying that I did not have enough time to finish the exam question because it was long, it was complicated, it was hard, it was tough. So I would take that all of that into consideration. But since this is pretty much the exam that we take home exam, so it should be a little harder than we have like 2 hours that we take in class. So I believe, so I really want to have you guys prepare for that. And for those of you who submitted the exams, congratulations. You're on the right track. And I try to keep up on the work for the final exam. So this is all I can tell. So any concern about the exam? I believe that um, I posed the exam two solutions right there. So the exam two solutions is literally 16 questions. I just have it here, and that's pretty much it. It's I would say I mean when I plan out a solution, it took me long because I have to type and I have to do all kind of integrations and things, right? But the real problem that I think that most of us have trouble was I would say um, I would say problem five because this is the problem that requires to factor this, right? So the factoring is actually a big deal. And after that, we get 4x plus 5 and 2x plus 3. If we notice that when you add them up, 4x plus 5 plus 2x plus 3, we literally going to get 6x plus a. And I mean, if we basically uh, good enough, and then we can figure it out. So 4x plus 5 plus 2x plus 3. When I add them up, I got 6x plus a. So a have to be 1 and b have to be 1 because when you multiply them, they have to be equal to 1 and 1. And that turns out to be a thing that we can break it up in terms of the two fraction. And that'll be, and this is using a chain rule for that. So this is 4x, so it have to be 1 4. And this is 2x, so it have to be 1 half of the ln of that because of the chain rule when you take derivative for this, or another word for substitution. Another problem that I feel like is really a big deal was the fact that we are having some trouble with the radical 81 minus x squared dx. When you when we try to evaluate it from a certain point, that would be a little bit too easy. Okay. But let's say I want to evaluate from 0 to 9. It's literally a quarter of a circle and the radius 9. But again, when we try to um, take the antiderivative for radical 81 minus x squared, so that we observe it is in the form of a squared minus x squared. So we have to let x equal to a size of theta. A lot of you concerned, can we do like cosine theta? The answer is absolutely yes. It doesn't matter. So when we're dealing with the sine cosine, the only thing that matters is if I let x equal to 9 cosine theta, then the dx will be equal to negative. Okay, so I do not want to have that to let it happen. So I let x equal size 9 size of theta. By doing so, want to take the dx, and I'm gonna get 9 cosine of theta. So I'm going to replace dx by 9 cosine of theta. I'm sorry, yeah, d theta, and I replace x by 9 size of theta into x squared. I'm going to get 81 size square of theta. So when I factor 81 out and I pull out the radicand, I got 9. Okay, so the inside of it will be 1 minus size of theta square. Okay, so 1 minus size of theta square, again, by the trig identity, so that would be the cosine of theta, and I take the square for that. So this is what we have, the cosine theta. And now we need to combine these two. So 80, this one basically equals to that. Let's cut 9 cosine theta. Let's just rewrite them as 9 cosine theta. And it turns out this guy equals to, so 9 times 9 is 81 cosine square of theta, d theta. And after that, so this is going to be a little tricky for that. And the reason why this is tricky because of the fact that we need to break it down in terms of, so 1 plus cosine, so 81, I pull 81 out, right? So cosine squared theta, I can rewrite this as 1 plus cosine of 2 theta over 2, right? Using the double angle for that. So this one will be 81 over 2, and 1 plus cosine of 2 theta, d theta, and the answer for that will be 81 over 2 theta plus 81 over 4. And then after that, we need to take the antiderivative for the cosine. So the antiderivative for the cosine will be size of 2 theta over 2, right? So I pull out 1/2 to 81 over 2, so I got 81 over 4 size of 2 theta plus a constant. But a constant doesn't mean anything. So, but I mean, we're pretty much done, except for the fact that we need to transform the theta into the x, right? So, and then given by that, I can say that the size of theta equal to x over 9. When you look at this equation, you can literally see that the size of theta will be x over 9. Okay? And meaning that the theta would be the x size of x over 9. So we take the inverse for that, right? We're going to take the x both sides, so x size of that. This is very straightforward. However, I need to evaluate the the size of 2 theta, right? And the very important thing that we have to use double angle rules that we have here, which is size of 2 theta equal to 2 size theta times cosine of theta. So this is what we call the double angle rules that we need to know what it is. So, and this is what we actually have before the outbreak began. Okay, so and now what we have to do is that we know the fact that size of theta, which is x over 9, this is what we have right there, right? Size of theta, which is x over 9. But we need to solve for the cosine of theta. So x over 9 will be, so we know the fact that size of theta will be equal to x over 9. X represent the opposite, right? So this is theta, the angle is right there. So x represent the opposite over hypotenuse, which is 9. Okay, so so that would be x over 9. And using the right triangle identity, I can solve for the b, right? So which is the radical of 9 squared minus x squared, and which is 81 minus x squared. So given that, I can figure out a cosine of theta, right? So the cosine of theta would be the adjacent, so that would be radical 81 minus x squared over hypotenuse, which is 9. And we end up getting that part, which is 2x radical 81 minus x squared over 81. Okay, and then after that, I'm going to take the cosine of 2 theta. I multiply by 81 over 4, and then so 81 cancel it out, right? So 2 and 4 we get 1/2. Okay, and then I rewrite x times radical 81 minus x squared, and that's pretty much it for the second term that we have. So we finished the second term. The first term, that'll be 81 over 2, and arc size of x over 9. And that's pretty much the thing that we have. Okay, so this is pretty much the thing, but the most complicated, it also is really complicated where we have the cosine of ln x, and this is what we have learned before. When you have the ln, or when you have the e, okay, or e or ln with the cosine, and then you gotta be really careful. Usually that we have to use integration by part twice, and I believe this is the part that I set of the equations. U equals to cosine of ln x, and so we differentiate the cosine of ln x that we're gonna get. So the derivative of a cosine is negative sine, right? And you multiply by the u prime, so the u is ln x, so we'd have to be multiplied by 1 over x. And we also have a dv equal to dx. There's no other term, so the dv have to be the dx, so v equal to x. And then I combine them, so that we're going to get the u dv equal to uv minus v du. So if we write the I in terms of uv, so the u is cosine ln x and v is x, so we multiply them uv minus v du, so v is x and du is negative size ln x times x, so we multiply these two together and x cancel it out, so minus this negative sign, this negative, and this negative side become positive side ln x. dx. Okay, and now we have to use integration. So very likely, okay, so why do we have to use another integration? Because we just convert from cosine to sine, okay? And now we're gonna take the sine and convert back to the cosine. And after that, I let the I equal to integration of cosine ln x. So sooner or later, and when we apply the integration by part, the second time, we're going to get back the cosine of ln x dx. So the whole reason of doing so is that, I mean, we do not continue working on it, right? So after we get the, so we're going to do the same thing for that part, which is u equal to sine of ln x, and then du equal to cosine of ln x over x, and we do pretty much the same thing. Okay, so the I here, and then we have another I. Okay, so I equal to x times cosine of ln x plus x times sine of ln x. I factor x out, and then the inside of the entire function turns out to be cosine of ln x plus sine of ln x minus I. Okay, so in this case, that you just basically have to solve for I add I both sides. I'm gonna get 2I equal to x times cosine of ln x plus sine of ln x, and I divide both sides by 2. I get the answers right there. So I would say that's pretty hard for this type of questions, but the other questions I would say is pretty okay. The cotan is actually somewhat difficult because we need to convert from the cosecant and um, and the cotan together. So in fact, that we need to use the formulas that the 1 plus cotan square, which is equal to the cosecant square. So meaning that the cotan square would be cosecant square minus 1, right? And then we multiply by the cotan. I mean, we break it down in terms of square and square, and then we just rewrite this term with the cotan. We're not going to do it both, okay? You just keep one. So essentially that and then we expand it. So the cosecant square times cotan square minus cotan square. So the reason why we can do this part relatively easy because of the fact that we can use substitution for that. But this part is going to be a little bit more challenging, and then that we have to apply the cosecant one more time. So on the other hand, that we can let the u equal to cotan of x, okay? So why do we have to let the u equal to the cotan of x? Because the du would be the negative cosecant square of x dx. So I can replace the cosecant square of x dx by negative du. So it turns out that we're going to get negative. So this negative side basically from the du. So we have negative u square. So the cotan square become u square du. So when you take the antiderivative for that by the power rule, then we're going to get negative u to the third over 3 plus c. And finally, I replace back u by the cotan raised to the power of x over 3 plus c. On the other hand, that the cotangent of square of dx, and then again, there's no antiderivative for that. So the easiest way that we can do, again, that we basically have to apply the cosecant with the cotan formula for that. So we know the fact that 1 plus cotan square equals to the cosecant square. So meaning that cotan square of x dx will be cosecant square of x minus 1. And we know the fact that a cosecant antiderivative, which is negative cotan, and 1 will be x. And then so we're going to combine these two, and then we're going to get this, subtract that, meaning that we're going to get negative cotan raised to the third power of x over 3, subtract this one, which is plus cotan x plus c. Okay, that's pretty much the things that we have right here. The first one is pretty much straightforward. And so all of these questions, again, that it was something that we have. And I believe that most of this was a thing. But again, that there will be some fraction that you see on the exam that we do not really solve for that, right? We just literally rewrite them with respect to ax plus b and c, A and B for that reason. This is what we have for the exam two review. But for those, some of you actually saw that, some of you solved them, so I do not count them. Okay, I only count up to the step where we got the constant, the unknown constant. We don't solve for that completely. And for a certain term that we just literally have to rewrite them with respect to A and B, and that's pretty much it. Yeah. Oh, really? I think I did that though. But did you guys do after step when you look at the exam two solution? I pretty much copied out the things. Did I? I pretty much copied out the things. So let me just do um. It, this is pretty much the thing. This specifies it. Computer definite integral and yeah, do not solve for the non-constant. Oh, really? I feel like I did everything here, and you can see that. Is it going not knowing about the do not solve for the non-constant for that? You only saw the equation. Oh, I feel like I specify everything for you guys, and even for every single question that I did, and that's pretty much the thing. But and then I even have people asking me the question. I even told exactly what's going on for that. I feel like yeah, you only saw the equation too. Oh, that's weird. I even every single question I did write them down for the short answers, compute the definite integral and proper. Okay, so if that's gonna be the case, might be the system. Okay. I tried to solve for the known. That was really hard, yeah. But if you can't solve for that, that's fine. I'm gonna count the thing that we go up to the step that we have, right? So what you can literally check. I'm not sure how the system did not really tell us did not really tell us the question type with the specified things, but anyhow, yeah. So yeah, I feel like that was the system, but on the final exam, I will change that. I will making sure that we do not have this happening. So for the second exam, I believe that this is a thing that we encounter. Okay, so and I will, for those of you who did solve them, I do not count. Okay, I do not really count for the part that you solve, even if you get it right or if you get it wrong. I didn't count them. I just basically agree the word you up to the constant, and that's pretty much it. If you do some etcher stuff, I mean, let me just check the etcher constant for that part. I feel like I did every single question for that. Let me see how hard that is. Exam two review videos. Exam two solution. Let me check that. And let me just check for the constant part. Is it hard and takes so long? I feel like it wasn't that bad. I mean, no, it's not exam two, exam solution. That was my bad. It was bad. Yeah, I did not really. Um, I would say A, B, and C, and that's pretty much the things. And that part was pretty straightforward. And this part was, I wouldn't say it wasn't too bad. It's something that A equals to zero. I'm sorry, A equals to zero, and B would be, I'm sorry, C equals to zero, and A, remember because of the review, uh, And so, and if you actually did for A, B, C, D, I did not count them. Okay. And let me see when the result is out, and I will let people know what's going on. But I feel like there was a system problem where we did not really have all of that planned out really well. But the final exam is whenever something happening like that. So, or I might just give you guys a question for that, and you guys can work on it for the final exam in this order. And again, that we experienced that, and but those question was something that we need to know how to evaluate it. And let me check if, because when we see the side integration, but most of the exam questions for most of the second exam question, like it tells you, would be something that we have to integrate them completely, um, except for the last four, the last 13. Let me see a fraction like that: 13, 14, 15, 16. So for these four questions that we do not, I'm sorry, we did not have to integrate them. So I believe that I count the time for you guys, for those of you who submit the exam in 5 hours, 5 or 6 hours for that, maybe 24 hours, which is all right. And I do not really take away point if you actually submit it with a long period of time. Okay, I feel like that's gonna be something that we follow the rules, and for the second exam. So is that fair? It's 24 hours. If take home exam, that I feel like that's pretty straightforward. I think I make a typo for that. That's what let's usually put it right here. I want to fix that so we don't see them. Anyhow, so that was the exam, two questions, and I believe that maybe there was some technical issue coming with the exam questions that makes it not able to see the question really well. But I will take all the consideration and just justify them. I do not really grade if you don't answer whether it is proper and proper. Okay, I do not really agree whether. The thing that I'm gonna grade is step and how we're gonna come up with the final answers. So that would be the most important thing. Okay, and that's pretty much for the second exam. Is that fair? So now we're gonna go to 9.1. So 9.1. Let me just check that real quick. So the 9.1 is literally pretty it's not bad equation, but it's also pretty, it's something that we basically learn before. So let me just rewrite them for the 9.1 sections. Okay, so um what is the 9.1? The 9.1 is literally something that we call differential equation. And I believe the PACE, they do offer a class called differential equation. This is where we will be going to study more seriously after Cal 3, but most of you actually don't have to do them. So that's pretty good. So the whole point of that is we try to solve the equation that involving the y second prime and y primes. Okay, and it's greatly important for people who study quantum chemistry, quantum physics. When we, organic chemistry, we don't have to see all of that, right? But physical chemistry, there will be something that, let's say, I want you dealing with the weight equation and light equation. Those are not really simple, so we did not really want to point it out, right? So, and what is the equation of a line when it's travel? And that's pretty much a thing that we utilize a lot of differential equation for that part. So it has to be in the form um, of the primes and maybe the x and maybe the y. And our job is basically look for the function that satisfies this equation. Okay, so it seems to be an easy task, but can you find me any functions such that we take a second derivative, and then I add the size of x times the original function equal to the first order, I mean the first derivative of that function. That is not easy, right? That is not easy. So because there's no specific formula that we can solve. I mean, we do when we study differential equation, there will be called a such a so-called a constant, the sine, cosine, or maybe e exponential function that satisfy that. And but this is not the thing that we study here because this is pretty much for the upper level of math. So we don't really we're not really interested for a certain case where we have to deal with a pretty, I would say, pretty complicated differential equation. So and but so again, usually that we're going to take the y primes as dx or dy over dx. But so this is something um, better that we rewrite them with respect to dx over dy over dx. So if you see a certain things on newspapers or anything like that, so that u dx dy over dx, so that basically equivalent to the y prime, but even better, the thing that shows us with respect to x, so we can see that the y prime, the first derivative of that, basically with respect to x. So for the y second primes, so the way that we write them down should be a little bit different. Okay, so a second order that we have to do the d square. D square meaning that you differentiate twice. Okay, you differentiate twice of y for the x. Okay, the x square basically for x, but you have to do it twice. So we rewrite them with a dx square. But some of you might be wondering why we do not do d square of x, because just the notation that people get easier. So for the n prime, for the n order, so it be, let's say you differentiate it n times for that. So we're going to rewrite d to the ny and over dxn with respect to x n times. So I would say this notation sounds a little clearer, a little more clear than that notation. So because we don't know if this one with respect to t or time or x or anything, so we gotta be really careful. Okay, but usually when the question only have two variable, either y is a function of x, so this one have to be with respect to x, and you can see that x, we have a psi x right there. So if you ask me how many differential equation that we have, I mean there are infinitely so many of them. You can set up your own. You can take to the fourth derivative of that, whatever it is. But generally, what we have so far will be a second derivative. Okay, a second order. There are a lot of homogeneous. So this is ordinary differential equation and inordinary differential equation. There's actually a lot of types of them, but we're going to deal with the very basic one. Okay, so the only thing that we seen before will be, I would say, the eight, right? So the gravity. So the gravity force is something that we have seen it before. Um, so and that literally equal to negative 9.8. Okay. Meter per second square. And if you ask me why we write them down like that, I mean, um, can we use feet per second? The answer is absolutely yes. So it's basically the same as 32 feet per second. So when we interested in gravity with a free fall object, so gravity for the free fall objects, um, this is the example where we have the positive, right? Because when you drop a ball, for example, so you're basically increasing the acceleration for this. So the acceleration that in this case would be equal to 9.8 meter per second square. So that would be equivalent to 32 feet per second square. So I mean, it doesn't really matter, but for most of you who study, um, let's say, um, physics, so usually that we use 32 feet per second square, but arguably the test will actually use 9.8. I was a little surprised. Anyhow, so this is so the acceleration that we have will be the second derivative for that. So we can rewrite this as y second prime, okay, equal to 9.8 meter per second. Okay, so and that's pretty much. This is the symbol. This is also called the differential equation, right? As long as I can see a certain uh, as long as I can see like an order of the differential equation, that should be all right. So I can just, so this is a second order for that, right? As long as I can see one sign, that should be all right. So, and then we claim that this is constant. Okay, so I want to solve for the original function for y. So what is the distance? So again, so y second prime, which is called the a, right? And which is acceleration. Let me just rewrite them so you can clearly see what's going on for that. And so the y prime, which is called as velocity, right? So from accelerations, we go to velocity, and we call v, and this one would be equal to velocity. And then the y that we have, and most of us say this is called a distance. I call s, right? And this is a distance travel. So apparently that we need to solve for the y function. So we need to find the y that satisfies this constant equation, really, this constant velocity, constant acceleration for that. And so we need to find y for this, find the distance travel. And so the way that we solve for this is literally a thing that we go into integrate them, right? So I integrate this one and both sides, and we can get y prime, which is equal to 9.80 with respect to t. Okay, so when you integrate with respect to t, so that'll be 9.8 t plus c, right? And so assuming that the initial velocity equal to zero, initial velocity equals zero. So we can assume that as well, and then we can literally solve for c. In this case, I mean, again, that this is what we just doing back from 6.1 or 6.2, where we have the equation and then we just do it. But this is just the thing that we did it before, and then so the initial velocity equal to zero, y prime. This is y prime. I'm sorry. Right, initial velocity, which is the derivative for the distance. So we call distance as y, so they have to be y prime. So and then so I plug in, this is with respect to t. This is a function with respect to t. So and then I plug that in, so zero. I plug in y prime is zero, so we're gonna get zero equal to 9.8 times zero plus c, right? So we're gonna get the y prime of zero equal to 9.8 times 0 plus c. And we can clearly say that c equal to 0, right? So c equal to 0. There's no doubt about it. And so and so what we have for the function would be y prime sub t would be equal to 9.8 t. Okay. So if we have initial velocity, it's basically you have to add something right there. So let's say the initial velocity was 2 feet per second, so that would be plus 2. And similarly that we have the equation, and then so we do it one more time. We do it one more time, and so we're gonna get we take the antiderivative for that, so we're gonna have to solve for the distance travel in this case. So that apparently we have y of t equal to 9.8 uh 9.8 t square over 2 t square over 2 plus c. Okay. And then, and so let's say we have the initial distance is 0 as well. I mean, this is pretty much the easiest thing that we can do. And then you plug that in, and then we're going to get c equals 0. Let's say this is C1 and this is C2. Okay. And so the C1 and C2 basic. So the C1 basically the initial velocity, and C2 is basically initial distance for that. And so, and then we can simplify a little bit, and then we can get the y of t, which is equal to 4.9 t squared plus c. Plus 0 for that, and yeah. So in other words, the general equations for the free for objects that we can literally see that so it seems to be so the general equation for the free for object is generally would be the y with respect to t. So y of t equal to 4.9 t squared plus v of t, yeah, v of t times t, right? Vt plus x0. Okay, and so let me just rewrite them so that would be clear. This is v0, and this is x0, where the v0 and x0 are basically initial velocity and initial height for that. Okay, so and specify that. So v0 and x0 is initial height. And so this is pretty much a thing that people see in physics, and I believe that it's not really too bad, but it was something that we can see with the equations y second prime equal to 9.8. So this is how we derive from it, and using the constant acceleration. And this is what we check them, and that is the constant things. And some people actually use 10 meter per second square instead of 9.8, but to be exact, it's actually 9.8 meter per second square. And so that's pretty much the thing that we have. And another application is if you study physics a lot. I do not study a lot of physics, but the simple friction is something that we dealing with, which is the m y second primes equal to negative k's times x. So this is with respect to the t. Okay, so for the time that is traveled, the frictions is so the negative k is basically um, the the constant, I would say, viscosity for that part is how much lubricant that the object can go. Okay, so the lubrication depending on the surface of the object. So when the surface of the object is really hard to go through, so then K gonna be really big. When the surface of the object is going very smoothly, so meaning that the K will be very, very small, but the friction exists constantly, and with the second derivative um, of the object M, with the M um, is the mass of an object. So we basically have to solve for the second derivative, which is y second prime equal to negative kmy. And this is also called second order because the highest order for that equation is second. Okay. And if we call it wet friction, is something that we um, do not really take the lubricant of the surface into account, then there will be a certain thing exists more. The first derivative, which is called velocity of that, and that's pretty much the thing that we're going to put them down. And it's also this is the second order, but definitely going to be a little harder compared to the first equation. So the application for that is something that we see. And we also use this approximation to help to study the pendulum's motion. And this is where we have a sigma, so you can see that how fast this can go backward and forward for that with respect to the sign. And so for those of you who study physics, that you definitely will see them. And you will be given an equation, but we never learn how to solve for that until we study a differential equation for that. So, and it gives us the equation, which is the y second prime plus g, which is the gravity over the L, and so that will be the length of the chord for that part. So, and of course that I'm sorry, the length of the string of that part. And so, and then the sign will be with respect to an angle that we have for theta, and this is with respect to the theta and with the angle that this pendulum is going to travel. But we did not going to be working on that very deeply for that part. I mean, this one is basically with respect to the sign, but we did not really spend time working on and how we're going to get to that original function. And so we don't really, we're not really interested in doing so, unless that you are required to do it. Okay, so so for example, we're gonna have the equations. So we want to check them. We want to verify if the general solution is given by this. So I claim that the general solution, this one is really complicated. But if you see, if that question shows up on the exam, will be something that we see for example 2, where we can deal with that relatively easy. But this one, when you have a second prime, second y prime plus 2y prime plus y equals 0, that is not simple. Okay, that is not. I mean, that is not too simple at all. So so we're not required to just solve something like that, but we need to verify the solutions, which is given by a times e to the negative x plus bx times e to the negative x would be a solution for that part for the system, right? And so let me just rewrite the question. So let's say we have y second prime plus I would say plus 2y prime plus y equals 0. So this is the initial solution. So I claim that the solution for with respect to x. So this is the solutions. Okay, I claim that of course we're not going to learn and how we deal with that complicated. I mean, a complicated second order. Um, it seems to be complicated, but when it go to like certain formula for that, it's not that bad. But anyhow, we're not gonna go through. We're not gonna do that. But we want to see if that will be a solution for this, and so that would be ax e to the negative x so plus b x times e to the negative x. Okay, so it seems to be a little bit challenging for us because of the fact that we how do we verify this is a solution of that equation? Oops, so let me just draw it. Yeah. How do we verify that this will be a solution for that, right? So the easiest way that we can do that we're gonna use what we learned for Cal one that we need to look for the first derivative for this. Okay, we take the first derivative, and so when we take the first derivative for that part, and we're gonna get so a and b are constant, so a and b are constant, and b a constant. So making sure that we do not get confused for all of that. Oops, let me just, I'm not going to draw it. I would just write them down. A and B are constant. So, and so now we're going to take the first derivative for that. So the first derivative that we can see, this one is, so we differentiate it first. We're going to get negative 8 times e to the negative x, right? Because we have negative side right there. So we're going to pull the negative side out. And plus, so this we have to use the product rule. I differentiate it first. I differentiate x. I'm going to get b times e to the negative x. And plus, I differentiate the second one. So I differentiate this guy. I'm going to get, so let me just, so that becomes negative because we have a negative x when you differentiate it using a chain rule, that we're going to get bx times e to the x, negative x. Oops. Okay, so, and now we going to differentiate the second derivative for that and to see if that's gonna, and then after that, after we take the second derivative, we're gonna plug back in to check if that satisfies this equation. So we're gonna take the second derivative of that equation. So second derivative, so negative become positive. We're gonna get 8 times e to the negative x. And we take this derivative for that part, we're gonna get negative b times e to the x, right? So why we have negative side? Because when you take the derivative from e to the negative x, we have negative sign in the front. And then we take that derivative, the basic thing that we do here. So we're going to get negative of, so I differentiated the x. I'm going to get b times e to the negative x. And after that, I differentiate the e to the negative x. I'm going to get minus bx times e to the negative x as well. So this is a thing that we have right here. So, and then after that, we're going to combine this two and the y second point. We're going to simplify a little bit. So we take derivatives, so we've got to be really careful. For this part, we're going to get a e to the negative x minus 2b e to the negative x, and then we have to plus b x and e to the negative x right there. Okay, so we going to do that, and then we plug that in. So we need to plug into the equations where we have y second prime plus 2y prime and plus y equal to 0. So we want to verify that. How can we verify them? So the way that we verified this equation wasn't that bad. We need to plug that in. So the y second prime that we have will be equal to a times e to the negative x minus 2b times e to the negative x plus bx times e to the negative x. Okay, I mean, the entire equation is right here. And plus 2y prime, so 2 times y prime. So what is the y prime? The y prime is right there. So we will going to rewrite the y prime with respect to negative a times e to the negative x plus b times negative e to the negative x. So I just rewrite the y prime with respect to negative a e to the negative x plus b times e to the negative x minus bx times e to the negative x right there. And we should be able to get it. Okay. And we add, so we add y as well. So we need to add this part. We add y, so the y is here. So y is a to the e to the negative x plus b x times e to the negative x. Okay, so now we're going to see that. So a to the ex plus a to the ax. So we're going to get 2, and 2 and 2 cancel it out, right? So this is positive 2 and negative 2a. So that want to be 0. So this is negative 2b. And we're going to get 1b plus 1b. 1b plus, so hold on a second. There was a certain thing that I wrote it wrong. Yeah, so negative 2b, and then this is positive 2b. I need to distribute that part. So positive negative 2 and positive 2, that's going to be 0 as well. And then another concern was this part. And this part will be bx plus bx, right? So and then you're going to group them. So we're going to get like this one and this one. We're going to get 2a e to the negative x. So this and this cancel it out, right? And so this guy, we're going to get this guy, we're going to get like a 2b e to the x. And this cancel it out, right? And then finally, that we're going to have plus bx times e to the x and plus bx. So we're going to get the 2bx and times e to the negative x, right? So this is minus, so minus 2bx. So this and this cancel it out. So the answer for that would be equal to 0. Check. So what I claim is that, so the yx, so this has to be the solutions, right? So this has to be the solution of that. Okay, so our job is either going to verify them or either going to solve a very simple differential equation. Okay, so it's not going to be really complicated as we have for the system, but it should be something that we can deal with on the review question and the exam questions. So it's not going to be something that going to like a truly terrifying thing. It might be a certain thing such that we we can see them immediately. Um, let's say we want to do the question number 8, right? So let's try it out this question and see. And very likely the final exam question will be a question like that, asking us to verify the general solutions for that part. And let's do it again for question number 8, that we can see yt equals to ct to the third power. So I claim that this is a solution. And what we're trying to do, I need to verify the ty prime minus 3 yt equal to 0. So we need to verify t y primes minus 3y equal to 0. So this is with respect to t. It's not going to be with respect to x. So you got to be really careful for that. And I need to verify that. Okay. So how can we verify this equation? So generally what we have to do, I just differentiate it, and this is pretty straightforward. When to differentiate the y, and apparently that we're going to get 3yt, 3c, t squared. Right, we bring that to power. So this is 3. Okay, and now we just plug that in, plug in the y primes right there, and we're gonna get the t times 3c on t squared. Just plug in the y prime, we just verify that, minus and 3y, so the y we have is c t to the third power. And we're gonna get that equal to 0, 0. Okay, so apparently that we need to solve for this, and we're gonna get 3 ct to the third, and we can see that 3c t to the third minus 3c t to the third. Of course, this is gonna go up to 0. So we check that. Okay, so there's so this one has to be a solution. So generally, we can, after we claim them, this has to be the solution for that. There's no doubt about it, because we subtract them, we multiply them, we multiply t and y primes, and we subtract 3y is 0, so it has to be a solution for that part. And so if you ask me how we can solve for that, is generally pretty easy, and in fact it was something that we can doing with the dy and dt, but we're not going to learn it now, but we might have to learn it for the future classes, and it should be very straightforward when we try to verify them. Okay, so let me try to do another example for that. Let me try with question number 10 that we have right here. And so we have yx equal to c1ex. And let me just draw the lines right here. We have the social distancing for that part, and we don't want to violate this. And we have here is Question number 10, y equal to c1 e to the negative x plus c2 ex. Y equal to y to the x, actually. So that would be c1 e to the x. Let me just check that. Oops. E to the negative x plus c2 ex plus c2 e to the x. And we claim that this is the solution for that part, which is y second prime of x minus y x equal to 0. And y second prime, again, this have to be minus y equal to 0 with respect to x. And we're going to deal with that. We plug in. Before we plug in, we're going to solve for the y prime of x. Right, so I differentiate this first. I'm going to get negative c1, right, because we have to apply the chain rule, so negative side is going to be to the front, and plus, so when I differentiate ex, I'm going to get the same thing, so that would be c2 e to the x. There's nothing changed for that part, and now we're going to have to take a second derivative for this. So second derivative would be the y second prime of x, and you can literally check. So negative negative become positive. And this one still be c2. So when you differentiate c2 ex, it's gonna be the same thing as c2 ex. I mean, this one would be very, very static. This one is gonna be very stable for that. And now we're gonna plug that in. So we're gonna get c1 ex. So the second, we're gonna plug in that equation to the y second prime. I mean, you can just literally check that. They subtract to each other. You're gonna get 0 for that. So plus c2 times e to the x, and then we subtract the y. Which, I mean, we basically subtract the same thing. This question is undoubtedly very easy for us to do so. I mean, we have a second derivative, second order derivative of the y, basically the same as the function that we have is something that we just rewrite them. And this one has to be equal to 0 for sure, 100% check. And so that's pretty much the thing that we need to know how to verify the equation using the rule that we have right here. And that's pretty much it. So now, yeah.
Did you forget to put the negative sign on the second derivative of c1 e to the x?
Yeah. So, but when we take we have a negative sign in the front, right? For
at the ex.
For the ex.
Yeah, in the second derivative, because you go from the first derivative, negative c1 times e to the
negative x. So I differentiate that, so that become negative, right? But we have to use the chain rule for that as well. So the chain rule for negative ex, so that become positive again.
Right, and then the ex does it stays the.
Oh yeah, I apologize for that. So it's
I was just confused.
Yeah, actually, yes. So this is something that I just wrote it. I'm missing it. Other than that, it's not going to be equal to 0 because they have to be the same thing. Because we can subtract them. If this is not the same thing as that part is something that we cannot do it. So that is a very good catch, and I apologize for the typo.
Thank you, Professor.
Yeah, very good. Thank you very much. And so now and again, that I'm so sorry. Sometimes we have those simple. And usually, if you actually caught up with that mistakes, I really greatly appreciate it. So, and now we're gonna go to again. There are actually more applications, but very likely that we would be applying. Is it can also be used to apply in statistics when we deal with when we're dealing with the big data sets and how we're gonna organize it. But generally, this is what we have to be doing. Okay, so um, now we're gonna have a question like that. This is gonna be the classwork questions, and for a particular solution to differential. Yeah, this one you have to integrate them. You take the antiderivative for that, and then I mean you have to integrate it twice, and after that we're going to plug in to solve for the constant. But this one is pretty. It's not that bad, but we're gonna do it later on. So this is a classwork question. So now we're gonna find a general solution. So the general solutions would be a certain problem. Let's say y primes of t equal to 5 cosine of t plus 6 sine of 3t. And so what we have is y prime equal to again. We usually have to rewrite them with respect to um, the t or with respect to the x. But since I assume that we know what it is, so I usually skip uh, the variable for that. So this is the y prime with respect to the t for the second example. And even if I don't write them down like that, but make sure that we write this on the exam so we can literally see it, since writing is not easy task for us. So that would be the phi cosine of t, and um, and then um, plus 6 sine of 3t. So regarding this questions that we literally just take the derivative for that, the antiderivative for that, and we get it solved relatively easy. But this part is not going to be easy. We can't just do it like that because they're not going to be same sign. And so the way that we solve for this is y equal to so the antiderivative for cosine is psi, right? Is psi of t, and the antiderivative for sine of 3t will be negative cosine of 3t over 3, right? So negative cosine of 3t over 3. So and let me just rewrite them. And cosine of 3t over 3. Oops. So and plus c. So making sure that we have to add a constant. So again, if the question said that we need to find a general solution for that, so meaning that there has to be a c for that attached to it. So the final answer that we have here would be the phi size of t and minus 2 cosine of 3t and plus c. So again, the reason why we call it general solutions, because we have a constant. Um, if the questions ask us to find a general solution, making sure that we leave out the answers with a constant. We can't just say, well, but when a questions ask us to find particular solutions, meaning that we need to solve for the constant by plugging in the initial condition either for y or for y prime. So this part would be, it's pretty complicated. So again, on the exam, I will not give us the third order of derivative. So we will never see a certain things like y third primes plus 2y equal to 0. So we're definitely not going to see something like that, right? So the highest order for us would be the second order in this class. I mean, can we solve the third order or n order? The answer is absolutely yes. They have the rule for this. Is the rule is not that bad. The rule that we play around pretty much the same thing that as we play when we're solving the second order, meaning quadratic, and then the third order, meaning the q root. I'm sorry, like the q power for that, and it's just something that we just play around, and we deal with that. But again, that we do not learn how to solve that equation. So, and now we going to finding the general solutions for a certain example. And for example, we have question number 21 again, that you can also check the answers on the back page of this chapter. Again, the book, we can download it using uh, a certain website that is sent out an email for everybody. And if you don't have the test book, please go to the web page and download it. It's free. It's free. It can be used for Calteri as well. And but try not to violate the order copyright, because this is not my book, and I can't just give it for free for everybody. So making sure that we're gonna keep that by yourself and keep the link by yourself as well, and then making sure that we just use it when we have a certain problem with this. And so now we want to verify using C1, C2, whatever. So let's try to solve question number 28 and see how we're going to deal with that. Again, that it's literally just we just take the antiderivative for that to solve for this. So v second order derivative will be phi over x squared. Okay, so let me just do that again. The second order of that would be 5 over x squared. So now we just finished the second exam, so meaning that most of the rest of the material would not be like the complications of integral. Okay, it's more like the combined things that we're dealing with, some application for that, and then of course that we still have to come back to the integrations at a certain point, but not going to be very deep down. Hard working on the integration using trick or a certain and integration by party technique, but it's more like general rule that how we're gonna apply them, and to solve for a particular uh, problem that we might have in any other field. So for this question again, that we're gonna take the derivative for this, and we're gonna have the v of x primes would be negative phi over x, I believe, right? So this one is, so we can take the antiderivative for this, right? So this is negative 2 plus 1 over negative 2 plus 1. So we're going to get negative 5 over x plus c, right? And since we're using C1 and C2, so we're going to put that as C1. And we do it one more time, and we finish the question. So divide the v of t would be equal to the negative of 5, right? So 1 over x antiderivative, apparently they're going to be ln x. And plus, so let me just check what kind of question that we have right here. So this is question number 28, I believe. So this one is something that we don't have solution. And so n plus c1x, right? So we have to take the antiderivative for this c1. You're going to get c1x plus c2. And that will be the final answers for that. There's no argue it. So let me just box this a little better. So, and what we have is something that we need to take the second derivative, second antiderivative for that, and then to get it solved completely. But again, that when we solve for second antiderivative, then we have to have two constants. The first that go with certain things, in this case, would be x, and the second one And so this is what we call general solutions. Again, when they say general solution, meaning that it have to be associated with the certain constant numbers that we have right here. Okay, so that's pretty much the thing that we have for question number 28. And so why don't we just solve for another solutions and see how it goes. So for certain questions, let's say, will not be as simple as we have. So let's say we look at the question number 38, that you can see that the problem that we have right here was, I feel like this is a classwork question. Should I do them? Yeah, that's pretty much the classwork question, so I can't do it. But so but let's do question number 37. So it's pretty similar to that. But 38 is harder because it's involving the e to the 2x, or when you take the antiderivative, so we gotta be really careful. And the y second prime will be 12t minus 20t raised to the third power. Okay. So y second prime will be 12t minus 20t raised to the third power. Okay, so and of course that we have the initial solutions. So because they have we have initial solutions, we need to solve for that. So y of 0 is 1, y prime 0 is 0. So we're going to get y of 0 is 1. And the y prime of 0 is 0. Yeah, that's going to be really nice, because you basically get a constant c equal to 0 for that. But and now we just literally, again, this one have to be with respect to t. Again, that I'm a little lazy for that, but usually that we have to rewrite this one with the dt, this one with the dx, just to confirm that we are doing it with respect to x, and this one with respect to t. And so the entire thing that turns out to be, so 12t will be 12t squared over 2, so that would be 6t squared. And minus 20t to the third. So when I take the antiderivative for t to the third power, so that would be t to the 4 over 4. So 20 over 4 is 5, right? And t to the 4. And plus c. And apparently that we can plug in. So I need to solve for c, right? So we call c1. And how can we deal with that? So we just plug in 0. So we have 0 equal to 6 times 0 is 0 minus 0 plus c is 0. And meaning that the c1 equal to 0 as well. And so that pretty much the thing that we get is solved. And meaning that the constant 0. So whenever they give us the initial conditions of the y prime is 0, so that with the c1 equals 0 for that for sure. And so this one is 0. And so now we're going to take the antiderivative to solve for y. Let me just redo that again. So I just rewrite the top. We're going to have, this is 6t squared minus 5t to the 4. And plus, there's no plus for that. So we take the antiderivative for this. And the y that we have is, so t to the third over 3. We take the antiderivative for that. And that becomes t to the third over 3 times 6 will be 2t to the third power. And minus, so t to the 4, so with 4 plus 1 over t plus 1 over 4 plus 1. So 5 and 5 cancel it out, so that would be t to the 5th. Okay, and plus c2. Okay, so and then we just plug in when y equal to 0, when t equals 0, y equal to 1. So this one is 1 equal to 0, right? And minus 0 plus c2. I mean, we're just basically doing back to the 6.1. It's more like a combined chapter, but 6.1 is something that we are unsure about how to solve the differential equation. But this part is very likely that we are learning what it looks like, and then we dealing with that, and we're gonna get c2 equal to 1. Okay, so and that's pretty much the things that we have here. There's, to be honest, there's no other concern that we can check right here. I would say the hardest part would be on the checking, because we have to take the antiderivative for that. Okay, so the hardest part will be on the checking. So I might guarantee you that you're gonna see maybe 1 or 2 questions like that on the exam, but we don't really go deep into how to solve, like using separable differential equation or the first order linear differential equation for that. And they're actually modeling with differential equations and all kind of things. We just literally just want to see what it is and verify these equations using the thing that we have. So the homework questions will be starting from, I would say, starting from questions number 7 up to questions number 32. I'm sorry, up to question number um, uh, 42. So I will specify what kind of questions that we're going to use for that part. Okay, so we're now going to talk about the magnetic fields and all kind of things using the differential equations. So this is something that we are not going to spend too much time working on it, right? And again, so all of that, we just basically take the antiderivative. And when we try to find the general solutions, and then we have to plug that in when we want to solve for a particular solution. And the next part was something that we need to plug in for to verify. So when we try to verify that, meaning that you can't solve for that, right? We do not solve for that. We haven't learned how to solve for that. In order to verify a general solution, all we need to do just take the derivative, usually up to the second one. There's no question that give us the third derivative for that. So second derivative, second um, the derivative for that, and it's also second derivative for this. And so all we have to do just, the question number 16 not going to be on the exam because it's go up to the third order of the derivative. So it's not going to be happening for that. It's just really, it's not complicated, but we have to do it 3 times. It's basically very time consuming. And the hardest part would be go up to the second order. And that's pretty much the thing that we have on 9.1. Any other concern? Any questions? Any concern for that? So now I would like to specify the people who really want to know the grade on the exam. So I need to see if you can type in if you really want to know the grade to me privately, and I can start grading the exam right now, and so that we can I can grade the exam for you guys if you want to see to know the grade. There will be 16 questions. There will be the 100 point for this, and okay, so no voices. Nobody wants you to know the grade, and yeah, I should give everybody 100 on that. And
I want to know
regarding
my grade, but not now.
not now. Okay, that's
not in front of everyone.
Okay, I sent an email in regard to the show to show your worksheet. Javon, can you send me the private message for that so I can actually double check them? I don't want to just to let the issue burn everybody in the classroom. I want to know will still be graded. If I no, absolutely, when you have your work and your answers, so that should be there. I will be graded accordingly. So one person I'm going to grade it first, and it will be John Jones, and that's basically the person that we're going to do it. And anyone else? Anyone that wants to know the grade? So I also heard that Jackie also wants to know the grade as well, but not now. Apparently, this is the thing. And so, and again, that we finished chapter 9. We're not gonna deal with chapter 9. Um, that was your use grades. I'm sorry about that. Oh wait, okay. I'm sorry, grades, and not now. Okay. You guys, you girls, voice south from you, for me, same as me. Anyhow, and so now when we come back next Monday, then we're gonna start a series. Series is not fun. Okay, series not fun. This is something that we but it's pretty good that we try to guess a certain series and number, let's say 1, 4, 9, 16, and 25, and all kind of thing. What is the next number? What is the next integer? It's my testing the IQ for that reason. So I really sometimes I'm a big fan of that. And so let's say we want to find the missing letter. What is the missing letter of that? A missing number of that. So we need to figure it out and using a certain connection, a certain pattern that according to it. But again, that I mean, the thing that we solve is way more complicated. But we're not gonna deal with a certain pattern too much. We basically go deep into what it is and dealing with the conversion and divergence that we have um, for the series. And that's actually really important when I can break down one functions into a one complicated functions like we have for the hard equation, right? And into something really straightforward. So this is might be helpful for some of you who study a computer science major, where I can break down any current model and using a combination of different functions that have a pattern. And so this is what the series is about, and it's really important. And so let's say there will be a certain function that I cannot take the antiderivative, and what should I do? I'm going to break it down into a mutable function, and then we take that. And that's pretty much the thing that we have for Cal 2 after the second exam, and we're going to deal with chapter 10 and chapter 11. Yes, this is the power up series, and this is the end of Cal 2. So if you really want to know how to is dealing with the other chapter, which is called a factor in geometry, how we're going to deal with the magnetic field and solving different order of antiderivative, and this is what we have the count 3 for. I mean, it wasn't that bad, but it's usually something that take long and a lot of patience to work through with it. But again, that for the rest of semester, that we're gonna quickly go through chapter 10 and 11, but not gonna be like deep down uh, knowledgeable about the concept and the chapter. It was just literally something that we want to utilize um, to deal with the final exams, how we're gonna do it well. Okay, so that's pretty much for today. And today I will post the classwork problem on Blackboard, and you guys going to have a time to do so. So by the times I'm gonna end the course here, I'm gonna end the course, and I'm gonna grade two people exams, and if so that would be the case, and I will post you see the grade Blackboard face and check them in 20 and 30 minutes for that. So again, when I grade on online, when I grade the exam on Blackboard, that would be a little more difficult for me because I don't really have the paper for that, and then they have to write down for each questions that you have the point that you didn't have the point. So it might take me a little longer for that. So in fact, if one exam take a week, it usually take 2 weeks. But I would try to grade it as soon as I can, right? So that I can see the grade and know what it is. Again, let me just repeat that again. The first exams will be 20%. The second exam will be 20% as well, right? and then the third exam, the final exam will be 40%. So it's gonna be a very, very important. And so we're gonna get 80%. And then the quiz that'll be 10%, and the homework and classwork combined would be 10% as well. And so the overall grade that we have would be 100%. So if you're not doing too well on the exam, so try to make up for it with the quizzes and um, and the homework problem and the classwork. Okay, so I'm trying to be a little bit lenient when I grade the classwork and the quizzes, and because I really want you guys to make up the grade for that. And but try to show me all the work you get wrong answers. Please do give you full credit for sure. And also there'll be a quiz number 4. That will be on chapter 9. On Monday. Again, that the quiz will be focusing on the differential equations, but not going to be like it's something really complicated. So it's something that I'm gonna give 2 questions. This quiz is gonna be really 2 or 3 questions, maybe 2 questions for that. And one question is asking you to verify general solutions. Another question will be asking you to find initial condition. To solve a particular solution for that. So you need to integrate them, and then we plug in X. Plug in the initial condition for that, and you solve for them. And that's pretty much the things that we have to do for the quiz. Okay, so and are we good?
Professor?
Yeah.
Just off-topic question. Would you be able to meet? Do you have like virtual office hours? Where
Yeah, so that will be from 5 to 6, usually on Monday and Wednesday. Yeah.
You said from 5 p.m. to 6 p.m.?
Yeah, from 5 to 6 p.m. for that. And I'm literally free, but before that, I actually have a lot of things to do. So I really can't meet you guys. Actually, I have to work. And after that, I will have free time from 5 to 6 and from 6 to 8. That would be the class time that we have. And this is a thing. So if you really want to meet up with me, and I will be going to post the link that you can call me on Zoom. So if you can't call me, I will call you. Okay, just email me, and I'm gonna set up the time if you want to see. I want to see a person one by one, not many people in a one single Zoom chat. So if one person's want to see me, so you have to wait a little bit. Okay, you have to wait a little bit until finish one person, and then another person can come in. So I really want to have some of the personal conversation that's going on. So if you really want to talk to me about the issue that we have for the exams, you're more than welcome to see me after that. Okay.
Yeah. Okay. It was more or less for like an issue, just if in case like I didn't understand something and I just wanted you to see like my screen so I could write on you would see the work and you could explain it just because
Absolutely. So that would be the case. If you have a certain thing like that, I'll be more than happy to help you out with that. This is the thing. So if you don't understand anything, just write them up on the screen, and of course I'm gonna see them, and you can share your screen with me. That would be great. A one-on-one is actually easier to share
Thank
the
you,
screen.
Professor.
Yeah. Instead of we have too many people. So again, I'm gonna post the classwork very soon on Blackboard. So again, how can I get the classwork problem? And you have to go to assessment. This is how we're gonna get all things graded, right? Quizzes and exam, and I would say classwork. So you're gonna see classwork number 11 down here very soon. Around 5 minutes for that, because I actually have a question but did not post them. And there will be homework chapter 9.1 right here. Will be asking us to do a certain problem. Will be posted for tonight. And okay, so that's pretty much it. I wish you guys going to stay well and stay healthy during this time and during this moment. And we're gonna see each other again next Monday.
Thank you, Professor. Have a good one.
Okay, have a great night, everybody.